Let's talk about some secrets to negotiation. Does anyone know the most powerful word in all of negotiation? No! Now, were you saying you don't know the word, or that's the word? That's the word. Very good. Okay, so the first secret is the word no. But there's a caveat. You have to be willing to walk away. Does that make sense? This is why it's so much easier to get a job when you've already got a job. So my wife and I graduate PhD 2006. We get precisely one job offer for the same place, and it's at the very end of the recruiting season. Do you think we had a lot of power to negotiate? No. But then a year later, we're talking to these folks, and for some reason they were trying to cheap out on my wife. And so I was talking to my future department head, and I said, you tell the dean that number needs to start with a, and I told him the number. It worked. Now, the only, oh, for shame, he's late. But he's got those crazy boots that Brad Pitt wears, so, you know, we're going to let him. Did you know Brad Pitt's from Springfield? Yeah. In fact, one of our former associate deans dated him in high school. Kind of weird. Back to the story. So you have to be willing to walk away. Now, I will tell you my favorite negotiation story. It's my 24th birthday. I'm sitting in a Honda dealership in Bethany, Oklahoma. I'm buying my first new car, right? And I'm all excited. It's a Honda Civic. And we're sitting there, and of course they're doing that stupid thing where the guy's like, well, I gotta go talk to my manager, right? That's the part of the negotiation. So they go off. Now, do you think he's really talking to the manager? No. He's just swilling coffee or smoking a J. I don't know. He comes back, but before he comes back, my wife says, you know, I'm kind of hungry. And I said, whew, we passed a Taco Bell on the way here. By the way, that used to be our favorite restaurant back when we were poor. So I said, like, yeah, I saw Taco Bell. She's like, okay, well, let's go. I said, great. So we get up, and we're walking toward the door, and the guy spots us. What do you think happens next? Yeah, oh, it's more than coming over. He chased us down, right? He's like, wait. I could go another $500. By the way, on a $15,000 car, $500, that's substantial, right? Okay, so I'm like, okay, write it up. We're going to Taco Bell. We'll be back, right? Going to Taco Bell saved me $500. I was going to have to pay for Taco Bell anyway, so it would not be what we call an incremental cost. We'll get to that in chapter 8. Okay, so that's the secret. Saying no and being willing to walk away. Now, last time, we had one slide left for chapter 10, and it was arithmetic average versus geometric average. And they actually answer a couple of different questions. And by the way, this is good stuff to have on your note sheet. This is good stuff to have on your note sheet. The arithmetic average answers the question, what was your return in an average year over a particular period? We say that estimate of return is probably too high for longer periods. Too high for longer periods. Now, geometric answers a different question. It answers what is your average compound return per year. Remember last time we showed you that you can have an arithmetic mean return of 0 and still be down 25% over 2 years. But once you take compounding into effect, then you start to get some better clarity on that. So it's what was your average compound return per year over a particular period. And we say it's probably too low for shorter periods. In fact, what I'm going to show you is as long as returns are positive, the arithmetic mean is always greater than or equal to the geometric mean. So let's do a little calculation here. So remember the formula is 1 plus r times, and you do all the returns like that. And then we take it to the 1 over n power, then subtract 1. So first of all, can we do this average arithmetic mean in our head? I hope so. 4 plus 12 is 16. We got the same thing again, so now we're up to 32. What's 32 divided by 4? 8. So we are at 8% right here. Now let's talk about over here. Hopefully you guys can do that in your head. What's the arithmetic mean over here? Yeah, it's also 8. By the way, the standard deviation of this one, 0. Why? Because it never varies from that arithmetic mean. Okay, now let's do the geometric mean. So we get our calculator out and we say 1.04 times 1.12 times 0.04 times 1.12 equal, and now what do we do with this number? Well, so we raise it to a certain power. Yeah, we raise it to the 1/4 power. So I'm going to say y to the x, open parenthesis 1, divide by 4 equals. Now, someone, I think, was telling me that we could just do square root. And that's absolutely true. We could. Okay, now I want you to notice this. The geometric mean here, if I subtract 1, multiply by 100, we're looking at 7.93%. And as I said earlier, it's going to be less than or equal to the arithmetic mean. Now, what is the only case in which it is equal to the arithmetic mean? If the standard deviation is 0. So let's do this, 1.08, and I'm just going to say square, because that's exactly the same as doing all that stuff. And then I'm going to take to the, 1 divided by 4 power, close parentheses, equal, plus 0, subtract 1. There we go, it's just 8%. So the highest the geometric mean will ever be is the arithmetic mean. If you have any variance, standard deviation at all, then you're going to end up with a geometric mean that's lower than your arithmetic mean. And that helps us to remember that this thing is probably too low for shorter periods, and the arithmetic's probably too high for longer periods. Now, that shorter, longer thing, if you want to know more about that, I have an amazingly rich academic article posted in the Chapter 10 folder that you can read if you're really interested. And if you want to discuss it, come by my office, just not today because of the dishwasher. So come by and discuss it if you're interested. Questions on anything in Chapter 10? Okay. Come on. Now we are on to risk and return portfolios. Okay, so far what we've been talking about is looking at one single asset and looking at the average return, and we're also looking at the volatility. How volatile is that thing? Now we're going to start talking about portfolios. Portfolios are a collection of assets, So you hear people talk about their stock portfolio. It means apparently they own more than one. Otherwise it wouldn't be a collection, it's just one. And we should now start to think about how that's going to impact the volatility or risk of our investments. Because it turns out if you hold two stocks or even other financial assets together and they don't move perfectly together, then now you start to get some diversification benefit. So if I've got one that's doing this and I've got another one that is doing this, what does the average look like between those two? It's not perfectly smooth, but it's a lot smoother, right? And so that's what we're going to get around to here. So in order to do that, we're going to have some language about how, some measurements about how these things move with respect to each other. So let's talk about, first of all, our vocabulary as far as we had been talking about average historical returns. That is, in fact, those average historical returns are our expected return. Expected return is going to take on a deeper meaning here in chapter 11, but I want you to know that an expected return is a swag. What's a swag? Oh, come on, I think I've told you guys this. It's a scientific wild-ass guess. Now, it's not just a wild-ass guess. There's science behind it, right? So what we're going to be doing is looking at the probabilities of different outcomes, multiplying that by the outcome, and then we're going to add all that together, and that's going to give us our expected return. Don't worry, I'll walk you through that. And then we talk about return variance and standard deviation. These are exactly the same as we talked about previously, except for in chapter 10, we looked at sample standard deviations. In chapter 11, we're actually going to mess around with population standard deviations. Remember I told you about the percentages? As long as those percentages all add up to 100%, which they better, then we know that we have basically every possible observation considered. And so then we start to use population statistics. And then finally, for the measurement of how these things move with respect to each other, we have covariance and correlation. And these both are going to measure how these things move with respect to each other. In fact, variance and standard deviation are very closely related. Covariance and correlation are closely related. And I'm going to show you how that all works. Are there any questions so far? Okay, here we go. So we have two firms here. We've got SuperTech and Slowpoke. And these two firms are operating at the same time in the same economy. Just like if you went out and bought two stocks today, they're operating at the same time in the same economy. And we have 4 states of the economy listed here. We have depression, recession, normal, and boom. And each one of those states has a probability associated with it. We have a 10% chance of depression. We have a 20% chance of recession. We have a 50% chance of normal, and we have a 20% chance of boom. Now, what do these terms mean? The only one up here that has a scientific technical definition is recession. Recession is 2 or more quarters of negative GDP growth. Recession is 2 or more quarters of negative GDP growth. Now, in the 80s, we were undergoing a recession. Our president was a guy named Ronald Reagan, and Ronald Reagan was doing a press conference. And one of the reporters said, "Mr. President, how do we know when we've gone from a recession into a depression?" And Reagan, without batting an eye, said, "In a recession, my neighbor loses his job. In a depression, I lose my job." Now, is that scientific? No. There's an emotional component with depression. Usually, you'll hear about a lot of people committing suicide over financial matters. Apparently, these people have not heard of bankruptcy. Okay, so that's depression, recession, normal times. That's pretty much the kind of average. And as you might expect, it's more likely than any of the others, which makes sense. And then boom, which is when returns are exceeding what we would consider to be normal. Okay, now let's talk about these two firms, SuperTech and Slowpoke. In a depression, SuperTech is down 30%. Does that sound like it's reasonable that a stock might be down 30% in a depression? Yeah. Garo says no. You think it should be more?
Yeah.
It depends on the firm.
Really?
Oh, we're going to get to that in a minute.
Like small companies or big companies?
Okay, it could be that, but more likely the product or service they're providing. We'll get to that. Okay, so in depression, it's down 30%. In recession, it's down 10%. In normal times, it's up 20%. And in boom times, woohoo, it's up 50%, which is pretty cool. We're talking about 1-year returns here. Now, in depression, for slowpoke, the return is 0. How many of you like 0 return? Man, back in 2008, 2009, I would have taken 0 return all day long, right? Because it was doing this. And so 0 return in a depression is actually a good thing. And in recession, you're up 5%. In normal times, you're up 20%, but in boom, you're down 5%. So you say, wait a minute, why in the world would anything be down in good times? Let's go back to your point. Let's talk about a company called Campbell's Soup. So Campbell's Soup is something that people would keep in their cupboard, and you know, when the kids are sick, you feed them Campbell's Soup. That's an American thing. And you let them watch Price is Right on television when they're home from school, which was like the golden age. Back to the story. What do you think happened? By the way, Campbell's Soup, is it expensive food? No. What do you think happened to the sales of soup when the Depression hit? Whoop, yeah. So there are companies that do better during bad economic times. Now let's bring it up a little more up to date. When you guys were starving college students, some of you still are, you probably ate a lot of ramen noodles. Ramen noodles are excellent food for poor people, right? But when you guys get out of here and you're making your wonderful MBA salaries, how many ramen noodles do you see in your future? Whoop, right? And so if everything were to go straight to hell, the ramen noodle stocks would go up, but the stocks of the steakhouses would go down. And so we have what are called luxury goods, and there may be 3 kinds of goods, but so there's definitely your what we call inferior goods. Does this mean they're of lower quality? No. It just means that demand goes up when the economy's taking a dump. Does that make sense? So those are inferior goods. And on the high end, we have luxury goods. So let's talk about potential luxury goods. A BMW automobile. You think they sell more of those in good times than in bad? Yeah. In fact, I'll tell you a story about, I was about to buy, and I'm so glad I didn't. I was about to buy an Audi A4, and I actually went out to the car dealership, and I had my checkbook. I was going to write the check, and to get the order started. And the guy says, "Now, are you sure that you want the jet black paint versus the metallic black paint?" I said, "Well, let's go take a look. We'll go out and take a look." And I said, "I don't know. I'm not sure. I'll come back tomorrow." I go home that night, and my neighbor, Larry, I ran into him and his wife in the street. Larry had recently lost his job. And they had this puppy. And I said, "Oh, what a cute puppy." And I said, "What's the puppy's name?" And they told me the puppy's name was Audi. I said, "Why is the puppy's name Audi?" And they said, "Because it's the car we always wanted, but now we'll never be able to afford." Do you think I went back out the next day and, no, Nissan Altima, baby, right? Oy vey. Okay, so you can see that even people who can afford to spend during good times might do so out of kind of respect for their friends and neighbors. So what kind of firm is SuperTech? Well, it's more like your BMW. And what about Slowpoke? I'll give you one last example of a luxury or an inferior good. In China, they have this white lightning kind of liquor called baijiu. And baijiu comes in all sorts of grades. So there's some that are like $500,000, $700,000 a bottle. But there are these big plastic jugs of baijiu that you can buy for not much. Now, in good times, which do you think is more popular? Yeah, the expensive stuff. But in bad times, it's that bottom of the shelf stuff. Does that make sense? Okay, so that's what we've got two probably different businesses going on here. SuperTech is more of a luxury good. Okay, now the next question is this. We want to find the expected return for these, and we can't just average them. And the reason we can't is because they all have different probabilities. They all have different probabilities. And so what we're going to do is we're going to come up with expected, I'm going to call it stock A. So for the expected return for stock A, which is SuperTech, we're going to say that there's a 10% chance that the return will be minus 0.30. By the way, there's an implied multiplication here. Okay, and then there is there a 20% chance of depression? Yeah, 20% chance that the return will be minus 0.10 plus a 50% chance that the return will be 20% plus a 20% chance that the return will be 50 or 0.50. Oh, whew. Now all we have to do is do that math. Now, you guys, I doubt you can anyone here do that in their head? Okay, so I'm going to show you how to do it on the calculator. We're going to take the first term. We're going to say 0.1 times 0.3 negative gives me, oh, wait a minute, that's not right. 0.1 times 0.3 negative equals. That doesn't look right either. Let's try it again. 0.1 times 0.3. There we go. Do you know how I knew it was wrong? Number of decimals was off, right? If I take 0.1 times 0.4, there should be 2 decimal places. If I take 0.01 times 0.4, there should be 3 decimal places. Hopefully they taught you that in grade school. Okay, so here we go, negative. And then what do you think I'm going to do with that number? Yeah, store 1. And then we've got 0.2 times 0.1 negative equal store 2. And then we've got 0.5 times 0.2 equal, what am I going to do with that? Store 3. And then I've got 0.2 times 0.5 equals, I'm going to store 4. Now, in order to get the expected return, all I have to do is add those things up. By the way, first thing I'm going to do is check and make sure that my percentages all add up to 100, or 1.0, right? So I've got 0.1 plus 0.2 is 0.3, plus 0.5 is 0.8, plus 0.2 is 1. If your percentages don't add up to 1, the problem's not going to work out. Okay, so now we've got all these. How am I going to add those together? Yeah, recall 1 plus recall 2 plus recall 3 plus recall 4 equals. And it's saying 0.15 or 15%. And I want you to notice that up here on the chart, it says expected return 0.15, which is exactly what we just calculated. In an exam, do you think I will give you that expected return? You are correct, I will not, right? Okay, so you need to know how to do this, but it's really, really not all that hard. So now let's do the expected return for B. And the states of the economy are the same, so I'm going to say 0.10. What is the return in depression for B? 0. Plus, there's a 20% chance of a recession. What's the return in a recession? Yeah, 0.05. Then there's a 50% chance of normal times, and the return would be 20%. Plus, there is a 20% chance of a negative 5% return. Okay. What happens here? Yeah, this goes to 0. And what happens to this one? 20% of 5% is just 1%. What happens down here? By the way, isn't this really the same number, only with a negative sign? Yeah. What do you think happens with those two? They just cancel out, right? Whoop, whoop, gone. So what's the only thing that's left? Half of 0.20. What's half of 0.20? Yeah, 0.10. And so the expected return for the second one is 10%. Now, could you have done that out with the calculator, store 1, store 2, store 3, store 4? Sure you could have. I just want you to see that sometimes it's easier just to think through things. Did I even have to know truly what this number was? No, I just need to know that these are the same things and one of them's got a negative sign, and then I know they can cancel. Make your life easier whenever you can. Okay, now remember when we were looking at individual securities and the statistic or the sample statistics, we said in order to find standard deviation, we're going to take the return in a certain situation and subtract the expected return. And that's going to give us the deviation. And so we're going to do exactly the same thing here. We're going to take the return in the state of the economy minus the expected return, and that's going to give us the deviation for that state of the economy. So for example, on SuperTech, we've got a return of minus 0.30 during a depression, and then we're going to subtract the expected return of 0.15, gives us minus 0.45 as our deviation. In a recession, we've got minus 0.10. We're going to subtract that expected return of 0.15, gives us minus 0.25. In good time, or in normal times, I've got 20%, and I'm going to subtract the expected return of 15%, gives us 5% as our deviation. And then finally, we've got 50% minus that 15% expected return, gives us 35% or 0.35. Now, can anybody guess what we're going to do with those deviations? What did we do in chapter 10? Yeah, we squared them, and we're going to do exactly the same thing here. We're going to do exactly the same thing here. And that's going to give us our squared value of deviation. But here's where things are different. Remember when we did the sample statistics, we took the squared deviations and we added them all together. But we can't do that here because these all have different probabilities. And so what we're going to do is exactly the same thing we did with expected return. We are going to figure out an expected squared deviation. How am I going to do that? Well, there is a 10% chance of my squared deviation being 0.2025. There is a 20% chance of my expected squared deviation, or my squared deviation being 0.0625. There is a 50% chance that my squared deviation will be 0.0025. And there is a 20% chance that my squared deviation will be 0.1225. So if we take the probability and multiply by each one of those, just like we did for expected return, we can end up with column 6, which is the product, which just means multiply by, the product of the squared deviation in column 5 and the probability in column 2. And then once we get all of those calculated in the sixth column, we can add them together and it's going to give me variance. We can add it together and it's going to give us variance. There is no dividing by n minus 1 or any of that crap. It's just variance. Okay, now let's talk about how do we do this? You're saying, wow, I sure hope he shows us an easy way to do this with the TIBA2+. Deep in your heart, isn't that where you're at right now? I have some bad news. Your calculator is smart, but it's not that smart. And so you're going to have to apply a little of your own smarts here. Now, I've been teaching this material since 2006. And over the years, I have refined this method that I'm going to show you. And I am confident it is the easiest way to do this problem and get the right answer. So let's get started here. I'm going to say clear. And what I'm going to do first is put in 0.15 store 0. Why am I putting that in there? Because we're going to use it again and again and again. So 0.15 store 0. And then I'm going to work my way across. Always work your way across, never work your way down. Keep everything in your calculator because you don't want to make a mistake writing it down, you don't want to make a mistake putting it back in, and you don't want rounding to come into the picture. Okay, so the first return, 0.3 negative minus, recall 0, equal. I get minus 0.45, which is exactly what we got earlier. What do you think the next step is? Yeah, we're going to square that. And that gives me this 0.2025. And then the final step is to multiply by the probability. The way to think about this is that there's a 10% chance that this is going to be the squared deviation. So we're going to say times 0.1 equal, that gives me this 0.02025. Any ideas what I should do with that number right now? Store 1. Okay, now we're going to take 0.1 negative minus, what am I going to subtract? I'm going to, say again? Yeah, I'm just going to say recall 0, right? I already stuck that in there. And so that's going to give me minus 0.25. What's my next step? I'm going to square it. And then what do I do next? Read, what do I do next?
You're going to multiply. What is it, 0.20?
Yep, very good. And then finally, Samuel, what are we going to do now? We've worked all the way across. We've got this number right here. What are we going to do? Store. Where are we going to store it? 2. Very good. Don't worry, I'll catch you on the next one, Samuel. Okay, here we go. The next one is 0.2. Subtract. What are we going to subtract? Recall 0 equal. That gives me 0.05. What do I do next, Miss Steele? Square it. And then, Samuel, what do I do?
Multiply.
By?
0.25.
By 0.25?
0.2.
0.2. Which one are we on?
The third one.
The third one. Ah, okay, very good. Multiply by 0.2. And that gives me, boy, I think something went wrong there. Let's try that again. 0.2 minus, recall 0, equal. And then I'm going to square it. And then I'm going to multiply by what? 0.5. The probability is 50%. I'm going to multiply by 0.5. And that gives me 0.00125. Where should I put that? Store 3. Okay, Samuel, I know you've got this now. Which number am I going to type in next?
0.2.
Oh, swing and a miss. That's the probability. So we're taking the return minus the expected return, gives us the deviation. Then we square the deviation and we multiply by the probability. Okay, so I'm going to try someone else here. Debbie, what number do I put in next?
You put in 0.50.
Very good, 0.5. And then I subtract what?
So you call
Recall 0, very good. And now what do I do?
you square it,
Square it. And then what's the final thing I do?
multiply by probability.
Yeah, which is how much?
0.20.
0.2. That gives me 0.0245. Where should I store that? Store 4. Samuel, I think maybe you need to study with Debbie. She's on fire. Okay, now we said when we got all of those numbers, we were going to add them together. How am I going to add all those together? Yeah, so I'm going to say recall 1 plus, recall 2 plus, recall 3 plus, recall 4 equal 0.0585. That number is the variance. That number is the variance. Camden, how are we going to get from variance to standard deviation? Yeah, we're just going to take the square root. Boom, there we go. So it's not shown on this slide. We'll see it later. But the standard deviation of returns for this thing is 24.19%. 24.19%. Okay, now it seems like you guys need me to work through the second one with you. So here we go. We are going to, what am I going to put in for, so what am I going to store in 0 here for the second stock? 0.1, that's the expected return, 0.1, store 0. And then I'm going to start by taking my 0 return minus recall 0 equal. And then what do? Yeah, we're going to square it. And then we're going to multiply by something. What are we going to multiply by? How much? 0.1, very good. Multiply by 0.1 equal. I'm getting 0.001. What am I going to do with that number? Store 1. Okay, now the next one is 0.05 minus recall 0 equals negative 0.05. What am I going to do with that number? Samuel, what am I going to do?
You multiply.
Multiply by what?
0.20.
Oh, we're not there yet. You're jumping ahead. I've got minus 0.05, which is this number right here. How do I get to this number? Someone want to help him out? Squared, very good, he got it. Okay, now, what do we do?
You multiply by 0.2.
0.2, or is it, yeah, 0.2, very good. Sorry, I made you doubt yourself there. 0.2, boom. I'm getting 0.0005. Where should I store that? Store 2. Okay, now we've got 0.2 minus recall 0 equal. What do I do with that number? Square it. Yarrow, what do I multiply by?
0.2.
Oh, swing and a miss. 0.5, thank you, Miss Steele. Morgan, right? 0.005. What do I do with that number? Store 3. Yeah, going crazy with the squaring there. Okay. So then finally we have 0.05 negative, what do I subtract? Recall 0 equal, I'm getting negative 0.15. What do I do next? Read.
You're gonna
Square it. And then I'm going to multiply by, let's see, is your name Vinicius?
Yeah.
Yeah, so what am I going to multiply by?
0.2.
0.2, very good. And then where am I going to store this? Store 4. Now, if I were going to try to figure out the variance for this thing, what would I do next?
So recall 1
Uh-huh. Recall 1 plus recall 2 plus recall 3 plus recall 4 equal. Abigail's on fire too. Okay, so we've got the variance of 0.011. One more step. How do I get from here to standard deviation, Jace? Square root it. I'm getting a standard deviation here for about 10.49%. 10.49%. Now remember, the standard deviation of the first one was 24 point something, and this one's 10.5%. Which of these stocks is riskier? Yeah, SuperTech. The first one is riskier. And we know riskier stocks should have higher returns. Does a SuperTech have a higher return than Slowpoke? Yeah. Now, there's some other stuff going on here. We're going to talk about there's more than one kind of risk. So not all of that risk might be rewarded, but everything is squared so far. Everything looks good. Okay, now here's where it starts to get hairy. Now we're going to try to figure out these numbers that describe how these stocks move with respect to each other. And we're actually going to start out by figuring covariance. And then we're going to use covariance to be able to get to something called correlation. Now, the chart that we have here, notice that the states of the economy are the same, the probability of each state is the same, and then we've got two columns of deviations. We've got the deviations from stock A, and we've got the deviations from stock B. And here, instead of just squaring the deviation of the stock, what we're going to do is we're going to take the deviation of A times the deviation of B. In fact, variance is just a special case of covariance. Variance is covariance of something with itself. So what we're doing here is looking at the covariance of stock A with stock B. The variance of stock A is just the covariance of stock A with stock A. And so that's how we end up with deviation of A times deviation of A, which is just squared deviation. Okay. After that, after we multiply those together, then we're going to do exactly the same thing we did when we looked at variance. We're going to take the probability and multiply it by that product of deviations, and that's going to give us our final column. And when we add that final column up, it's going to give us something called covariance. It's going to give us something called covariance. So here we go. Let's see, let's get our calculator out. And I'm going to figure out the deviation first, or the product of deviations, and then I'm going to multiply by the probability. So I'm going to put in 0.45 and 0.10. Do I need to put the negatives? No, why not? Yeah, they cancel out. So a negative times a negative is a positive. So just to save time and space and steps and mistakes, I'm just going to put those both in as positives. And sure enough, we come up with 0.045. Now, I'm going to multiply that 0.045 times the probability. The probability of depression is 10%. 0.1 equal. What do you think I'm going to do with that number right there? Store where? Store 1. Now, we're going to say 0.25 times 0.05. Why didn't I have to put in the negatives? Yeah, they cancel out anyway. Why waste your time? And we're going to multiply that by what? 0.2, which is the probability of recession. And so I'm getting 0.0025. What am I going to do with that number? Store 2. Very good. And then 0.05 times 0.1 equals 0.005. And I'm going to multiply by what? 0.5 equal. And where am I going to store that? Store 3. Very good. And then I'm going to say 0.35 times 0.15. I have to use the negative. Why? Yeah, there's only one of them. It's going to show up. So I'm going to say equal negative 0.0525. We got that. What am I going to multiply? Yeah, multiply by that probability of 0.2. Oop. Divide by 10. So I only got a 2. And let's see. There we go. Minus 0.0105. And what am I going to do with that? Store 4. Now I'm going to point something out to you here. The product of deviations. As long as these things are headed in the same direction, that product of deviations is positive. If they're both headed in the positive direction, positive times a positive is positive. If they're both headed in the negative direction, negative times a negative is positive. As long as they're both headed in the same direction, then we're going to end up with a positive product of deviations. But what happens when they're headed in opposite directions? Yeah, it's going to be negative, right? And the question here is, what's going to be more important here? Is it going to be that negative? Or is it going to be the 3 positives? There's only one way to find out. How do you think we get that covariance there at the end? Yeah, very good. Recall 1 plus recall 2 plus recall 3 plus recall 4 equals. I'm getting minus 0.001. So which one predominates? This or this? Yeah, the negative, right? And so what we can say is, at least in some small way, these things are moving in opposite directions of each other, at least in some small way. And the reason I say that, we can't, just like we can't look at variance and get a good idea because we can't interpret percent squared, this has got the same units, right? This is also percent squared kind of unit. So we can't really contemplate that. We can't comprehend it. And you say, well, wait a minute. I know how to fix that. How did we fix variance? What did we do? Yeah, we just took the square root of it. I'm going to ask our math major, Camden. What happens when you take the square root of a negative number? It's not something that we're going to be able to do in a finance class, right? In mathematics, you get something called imaginary numbers. And it starts, oh yeah, it'll blow your mind. By the way, we actually use those in electrical engineering, strangely enough, to model real-world phenomena. It sounds like our student in the back actually knows about that. Sweet. Do you use it in chemical engineering too? Oh, wow. Okay, so I've learned something new today, not just electrical engineers. We called them Sparkies. They didn't like that. Okay, back to the story. Now, what I'm telling you is we can get a little bit of information about this, the fact that it's negative versus positive, but we cannot really make any great insights using that number. We just can't interpret it. So what are we going to do? Well, now we're going to do correlation, and that's going to be something we can interpret. Now, how am I going to get that correlation? Well, I'm going to take the covariance that we just calculated, and I'm going to divide by the product of the standard deviation of A and the standard deviation of B. So remember that covariance has percentage square units. Standard deviation has percentage type units, and so does standard deviation. And so what happens to all the units when we do correlation? Yeah, they all cancel out. In other words, correlation is unitless. And you say, way to go, dipshit. You went from something that we could interpret percentages down to something with no units at all. But do not despair. Correlation has this amazing property. It only runs from -1 to +1, and there's a 0 in the middle. And so we know that it's bound. And so what we're going to do is next we're going to figure out this correlation, and we're going to figure out where our number is on that line. So here we go. We've got our correlation, or covariance of negative 0.001. And then we're going to divide by the standard deviation of A and standard deviation of B. Notice we have our variances from before, and then we've got the little caret symbol. What's the little caret symbol mean? It's raised to the power up, right? It's the exponent. And then to the 0.5. By the way, taking something to the 0.5 power is exactly the same as square root, right? And so what we're really looking at here are the square roots of the variances, and lo and behold, the square roots of the variances are standard deviations, right? Okay, so now I'm going to take that minus 0.01, I'm going to do that math, and the answer I get is minus 0.0394. So the question is, where does minus 0.0394 land on this line? About right there. It's about 4% of the way over to minus 1. By the way, plus 1 we call perfectly positively correlated. Minus 1 we say perfectly negatively correlated. 0 we say uncorrelated. 0 is uncorrelated. Now, our portfolio, or our two stocks, are right here. Would you say they are more likely negatively perfectly correlated, uncorrelated, or positively perfectly correlated? Yeah, they're more likely uncorrelated. We know that they're slightly negatively correlated, but is it really a big number? No, not at all. Questions?
Where did you get the 0.0585?
Good question. Do you see the variance on A? And so if we just take the square root of that, we get the standard deviation of A, and it's the same thing down below. Good question.
Would you say for this correlation, would you say it's closer to uncorrelated, or would you say it's a weak negative correlation?
I would say it is very weakly negatively correlated. Really close to uncorrelated.
Why is it to the power of 5?
I-
Is it normal?
To the power of 0.5. We're just taking the square root of the variance to get standard deviation. So that's why we're taking 0.0585 to the 0.5 power. That's exactly the same as taking the square root. How do we get standard deviation from variance? We take the square root. Good
Does it
question.
make a difference, like on the business calculator, like why you're specifically doing the half exponent as opposed to just pressing the square root button?
Oh no, guys, the only reason it says that on the slide is because I could not figure out how to do the little square root sign. So no, oh no, don't freak yourselves out there. Use the damn button. That's what it's for. Oh, thank you for bringing that up. I'm glad. Yeah, it does the same thing, but it's a whole lot easier just to hit the button. The year was 1975. My dad bought his first electronic calculator, and he was the big guy down at the dynamite plant laboratory because his calculator had a square root button. Yeah, $300 in 1975. That was big freaking money. Yeah, okay. More questions? Okay. Now let's talk about why correlation is a superior measure of relatedness. First of all, it doesn't have that percent squared problem. The second thing is that we know that it's bound. We've already talked about that. And so it's a whole lot easier to interpret than covariance. A whole lot easier. And so we've already answered that last thing. I would say it's very slightly negatively correlated, but for the most part, it's actually uncorrelated. So here we have some pictures, and a lot of times people get confused, and they think if something is perfectly positively correlated, it has to look like this. If stock A is up 2%, stock B is up 2%. If stock A is down 1%, then stock B is down 1%. If stock A is up 3%, then stock B is up 3%. And that's true that that is perfect positive correlation. However, it could also be this. Stock A is up 4%, stock B is up 2%. Stock A is up 2%, stock B is down 1%. Stock A is down 2%, stock B is down 1%. As long as I can take the return of one and divide it by the return of others and always get the same positive number, then they're perfectly positively correlated. Now let's talk about perfect negative correlation. Of course, we could say this one's up 4, this one's down 4, this one's down 2, this one's up 2. That would be perfectly negatively correlated. However, it could also be this one. This one's up 8, this one's down 4. This one's down 2, this one's up 1. This one is up 4, this one's down 2. As long as I could take the return of one, divide by the return of the other, and always get the same negative number, then they are perfectly negatively correlated. So they don't have to move exactly together. It's just an order of magnitude kind of thing. As long as you could multiply the movement of one and get the movement of the other always with the same number, then you're either perfectly positive or perfectly negatively correlated. Now, uncorrelated is down at the bottom. And that's where the movement of one has not one thing to do with the movement of the other. The movement of one has not one thing to do with the movement of the other. Do you think there are a lot of things in this world that are perfectly, or that are uncorrelated? It's really rare to find. I'll give you an example here. Some finance colleagues of mine did a study where they looked at every possible data series that was available for them to look at. And they found that the best predictor of the return on the S&P 500 was the price of butter in Denmark. Does that make any sense? No. So here we have two things that we don't believe should be correlated at all, and in fact are highly positively correlated. That's why I'm telling you, if you go out there and you're just on a fishing expedition for things that are uncorrelated, your chances of finding it are pretty low. So I was giving this talk, and I was talking about the economy of the United States and that lots of other countries are correlated. And so I had two students from Ghana in that class. And they said, no, our economies are totally uncorrelated. I said, what are your primary exports? And they said, gold and chocolate. Or yeah, gold and cocoa, right? I'm like, okay, who do you think is buying the chocolate? Europeans and Americans, for the most part. And I said, who's buying your gold? China and India. Chinese are the big ones, right? Well, it turned out, and I asked them this, where do the Chinese get their money to buy your gold? And where do the Europeans get their money to buy your chocolate? Right? Selling us German cars, fine machine tools, all sorts of great stuff. What I'm getting around to is it's really hard to find things in this world that are uncorrelated. Okay. So let's talk about the expected return for a portfolio. Remember that we said an expected return is just a swag, scientific wild-ass guess. And so what I need to do to be able to find out an expected return for the portfolio is take the portfolio weights times the expected return for each thing in the portfolio. Okay, so we already know the expected return for SuperTech is 15%. We know the expected return for Slowpoke is 10%, but we don't know anything about portfolio weights until they tell us that we've got this $100 portfolio with $60 worth of SuperTech and $40 worth of Slowpoke. Now, if I told you there are only two assets in there, would I have to tell you that the total value was 100? No. What would you do to find that total value? Yeah, just add the values of all the assets together and it tells you the value. Now, how do I find the weight of those individual assets in the portfolio? I take the market, by the way, these are market values. I take the market value of SuperTech and divide it by the market value of the portfolio. And that gives me the portfolio weight on SuperTech, which is 60 divided by 100, or 0.6. And then I take the market value of Slowpoke, which is 40, divide by 100 gives me 0.4. So that is the portfolio weight on Slowpoke. Now, one thing I want to point out about portfolio weights, go ahead and calculate them all individually and then add them together. And you add all your portfolio weights together, how much should they sum to? Yeah, 100% or 1, right? So your weights always have to add to 1 or you've done something wrong. So that's the perfect way to check it. Sometimes students will add up the first however many and then just subtract from 1 and then get the absolute value of that, use it for the last weight. They're throwing away an opportunity to check their work. So don't do that. Okay, so what do we do here? We got the weight on A times the expected return on A, which we said was 15%, the weight on B times the expected return on B, which we said was 10%. So that first part is 9%, the second part is 4%. 9 plus 4 is 13. So our expected return on that portfolio is 13%. Now it makes perfect sense that the expected return is going to be somewhere between A and B, right? If we've only got 2, the portfolio return pretty much needs to be between those numbers. If it's not, you need to go back and check your math. Okay, now I will tell you one other thing here. When we are figuring, especially when we get into figuring portfolio standard deviation, sometimes it's actually easier to figure out the expected return of the portfolio in each situation. And then we'll use that expected return on the portfolio in each situation to come up with an overall expected return on the portfolio, like our 13% here. But the other thing that we can do is then treat those different expected return things as our like returns on an individual stock. And it's actually easier to find the standard deviation of returns on a portfolio that way than to find it in the way that I'm about to show you. And you say, wait a minute, there's an easier way? Yes. How can I learn this easier way? Look under the Chapter 11 example videos, and I walk you through it. In the Chapter 11 example videos, I walk you through that. And of course, if you've got questions, I'm glad to answer them. Okay, so now we've got the expected return. Well, hey, that wasn't too bad. But now we get into the variance of a portfolio. This is where the crap hits the fan. We have this formula here. The variance of the portfolio is equal to the weight on the portfolio weight A squared multiplied by the variance of A. By the way, that's the portfolio standard deviation, and then, the standard deviation is omega, and then squared gets us up to variance. So I've got weight on A squared times the variance of A plus weight on B squared times the variance of B plus 2 times the portfolio weight on A, the portfolio weight on B, times that last thing there is the covariance of A with B. That last thing is the covariance of A with B. Now it freaks people out because you say, wait a minute, if it's just a single one of these, isn't that standard deviation? No, not if it's followed by 2 letters. If it's followed by 2 letters, it's the covariance of A with B. It freaks people out because it has exactly the same units as the squared standard deviations, which are variances. Okay, so we've got all those numbers. We have those portfolio weights, which you just calculated. So we've got the portfolio weight on A, which is 0.6. And in fact, I'm going to go ahead and work this out for you. So I'm going to say 0.6, and I'm going to square that. So that's what that is. Then I'm going to multiply by 0.0585 equal. I'm getting 0.02106. What do you think I should do with this number? Store 1. And then we have 0.4 squared times 0.011, which was the variance of B. That gives me 0.00176. What should I do with that? Store 2. And then I've got that last term there. 2 times 0.6 times 0.4 times 0.001 negative equal. What should I do with that? Store 3. Okay, how am I going to come up with the variance for that portfolio? What do I do? Yeah, recall 1 plus recall 2 plus recall 3 equal. I'm getting 0.02234. Now I am going to get to standard deviation from there. What do I do? Take the square root. And I'm getting 14.95%. 14.95%. Remember that our bottom one was like 10.5% and our top one was like 24.2%, something like that. That number falls in between. And so it passes our first stink test. But I'm going to show you that it actually could be possibly lower than. I'm going to blow your mind with that one. Okay, now, what if we have 3 assets in our portfolio? By the way, this is just for a 2-asset portfolio. Let me see if I could do a 3-asset portfolio here for you. XA squared times the variance of A plus XB squared times the variance of B plus XC squared times the variance of C plus, here's where it gets bad, 2XA XB covariance of A with B, 2XB XC covariance of B with C plus 2XA XC covariance of A with C. This thing just grows crazy as we add more items to the portfolio. I have, at last count, probably somewhere around 3,000 stocks in my portfolio. How big do you think the equation would be? It would be huge. So what am I telling you? Do we actually use these equations for figuring these things out? No. We're going to use a spreadsheet. Why in the world would I show you this? Because I'm going to use it to prove something amazing and magical to you. So the question is a portfolio standard deviation just the weighted average of the standard deviation of the component's asset returns? You might say, well, wait a minute, the expected return was just the weighted average. Then maybe the standard deviation is too. So let's find out. If we took 0.6 times the standard deviation of A, which is at 24.2% roughly, and added 0.4 times the standard deviation of B, we would come up with the neighborhood of 18.71%. That is higher than our actual number. Why is that? You remember early on I said if we have things that aren't moving together perfectly, that we're going to be able to get rid of some of that risk because it smooths things out? That's exactly what's going on here. Because we're holding both of these things together in the portfolio, then we are getting something called diversification benefit. So let's demonstrate what this means. What we're saying is if I add anything to the portfolio that is not perfectly positively correlated to the portfolio, then I can get some diversification benefit, which means I am eliminating some risk. If I could eliminate risk without eliminating return, to me that's pretty magical, right? I can eliminate risk without eliminating return, all because of the different assets I choose to hold. Okay, so I will demonstrate to you how this works. So here is the formula we've been using so far for our 2-asset portfolio. And I want you to know that we also have this formula for correlation of A with B. and it's just the covariance of A with B divided by standard deviation of A times standard deviation of B. I can rearrange that using the magic of algebra and come up with something that I can substitute into that equation for covariance of A with B. And it's just correlation of A with B times the standard deviation of A times the standard deviation of B. So all I'm going to do is take this and replace this with it. That's called the substitution principle, and it does not break any laws of mathematics. So we substitute back in, and now we have this formula. By the way, should you have this formula on your note sheet? Yes. Should you have this formula on your note sheet? Yes. And you need to read the problem. You need to read the problem and figure out whether I've given you correlation or covariance. You need to read the problem and figure out whether I've given you correlation or covariance, because you're going to use the top one if I've given you covariance. You're going to use the bottom one if I've given you correlation. I'm going to wait till the writing stops. Okay.
You said just one more time.
Okay, so if I give you covariance, use the top formula. If I give you correlation, use the bottom formula. And how do you know? You have to read. Read the problem first before you write anything down. So, what if the correlation is perfect? Well, I just take that formula I just came up with, and you guys recognize all those numbers. I'm going to throw a 1 in for correlation. If they're perfectly positively correlated, the variance of the portfolio comes out as 0.035. I take the square root of that, and I get 18.71%. Does that look familiar? Yeah, it's just the weighted average standard deviation. So what are we saying here? The only case in which we do not get diversification benefit is if these things are perfectly positively correlated. Does the correlation have to be negative to get diversification benefit? No, it just has to be less than 1. I could prove it to you. Throw 0.5 in there instead of 1, and you'll notice you still get a reduction. 0.5 is still positive, right? Anything less than 1 correlation is going to give me less than 18.71%. I will have achieved some of this magical diversification benefit. Now, remember earlier I said hardly anything's uncorrelated? Hardly anything's perfectly positively correlated. For example, Royal Dutch Shell has 2 stocks outstanding, one in Holland, one in the UK. They are exposed to exactly the same risk and everything else. And yet, what do we see? Not even the returns on those 2 stocks are perfectly positively correlated. So in theory, you could gain some diversification benefit from just holding both stocks for the same company. Now, does it help the lower your correlation is? Absolutely. And what would our favorite correlation be to reduce risk? -1. If we could get perfectly negatively correlated, then that would be the best. Now, the question is this: can I find 2 things that are perfectly negatively correlated? And I used to say no. And then the guy's like, well, what about the S&P 500 and the anti-S&P 500? It's like a fund that goes the opposite direction. Yes, they are perfectly negatively correlated, but what do we know about their expected returns? Let's say the expected return of the S&P 500 is 12%. What would that mean the expected return of the anti-S&P 500 is? -12%. If I've got a portfolio of both those things, I add them together, what do I get? What's my expected return? 0. Now, remember I told you that we can get the risk-free rate for just investing in treasury bonds? I'm losing money by making that trade. So what you have to have are 2 things with positive expected returns that are perfectly negatively correlated. If you ever find one of those, please come to my office. We will get rich together. I've been making that offer for 20 years now, and I've not had a taker yet. Any questions? Yes?
Why is it multiplied by 2 at the very end?
Oh, okay, that's a good question. Because there are actually two of these. There is an XA, XB correlation of A with B. There's an XB, XA correlation of A with B. And when we just add them together for the sake of the formula. Yeah. Oh, we could blow the whole thing out, but it's a big pain in the ass.
So if there was more stocks to it, then we would be multiplied.
Nope, it's always going to be 2 because we're only looking between 2 stocks. Remember, a correlation or covariance can only be between 2 stocks. And so basically, we're looking at XA, or we're looking at A with B, A with C, and B with C.
Earlier you mentioned, there, like very beginning, that there were some risks that cannot be diversified. Do those
Yep.
ever get factored into the variance and correlation calculations?
Yeah, so we're seeing this difference between 18.71% and 14.95%. That difference is that diversifiable risk that we're getting rid of. But we'll get into it more further in the next set of slides, the capital asset pricing model. Other questions? Okay, thanks for sticking with me. I'll see you next time.